Hi guys, welcome to the flipped instructional recording for the Laboratory Energy 1. This is your first teacher graded assignment, so I wanted to make sure you had a clear understanding of what needs to be submitted. As you go through, you may want to take a couple of notes during the recording. You do have guiding questions in this lesson to add to your science notebook, so please don't forget to do that. And update your slides in your science notebook with the lesson number and title. Make sure you are doing that as well. So as we get started in the lesson, it starts in 1.12. You can always get to the lessons by your science homepage and then clicking content and scrolling down to the lesson that you need to be in. So with 1.12, this is the first part of your science experiment. There are instructions here that kind of guide you through. And then we'll open up with the first part of the lesson. So we're talking about a system of objects may contain potential energy. So in this lesson, we will conduct an investigation to observe how the height that a ball is placed on a ramp affects the amount of potential energy stored in a system. So here's the worksheet that you're going to want to print out. I encourage you to do that now and maybe even pause the recording because you're going to see answers to these questions as we go through each of these slides. So if you want to pause and print that out, you'll notice that the answer for number 1, which is what is the purpose of this experiment, is right here. What are we doing? We're conducting an investigation to observe how the height of a ball is placed on a ramp and how that affects the amount of potential energy stored in a system. So you need to go ahead and print this page. It does need to be in a Word document so that you can type on it. For those of you that are Mac users and trying to convert it to a Pages document, it will not upload into our system. So you do need to have Microsoft Office downloaded. If you have a problem, you do have a free, it comes with your tuition, it's in your email, the Outlook program, you're able to download Microsoft Office. If you need help with that, reach out and I can help you. But you do need to be able to have access to Word and PowerPoint. So as you go through, it talks to you about the lesson goals. We're going to be talking about the variables that are used in this experiment. What tools are we using to do the investigation? How do we do the investigation? We're going to collect data recorded in a data table. We'll be developing a model to describe unobservable mechanisms. We are going to apply scientific ideas to construct an explanation for real-world events. We'll represent those systems and their interactions using a model. You're going to define kinetic energy as the energy of motion. So there is something that should go on your left side of your science notebook template. The left side is your personal notes. So you've got a definition here. It also shows you how to calculate kinetic energy. You've learned that in the lesson, so hopefully you have that formula in your notes. You're going to know that describing stored energy is potential energy of a system. It's based on their relative position. So we know that height is a factor. If an object's on the ground, it has 0 potential energy. But if it's the higher it is, the higher potential energy. And then you've got a system of 2 stationary objects that interact. So we're going to be able to describe that, describe the distance between 2 objects, make sure you know potential energy is also stored energy, and then describe how the relative position of 2 objects with potential energy of the system changes. So here is your here are your 2 keywords you need to have in your notes. And then here are your guiding questions. So these need to be, you can copy and paste them, you can handwrite them, however you're doing your science notebook, but those need to be on the right side. So as we get into the experiment part of the lesson, it is a simulation again. So it is something you're watching and manipulating on the screen. You are not doing this finding a marble and a ramp on your own. So we're talking about the law of conservation of energy. This is something I would put in my notes. It states that the total energy of an isolated system remains constant. And we know that a system is an organized group of related objects or components. So there's another definition for your notes. The earth and a ball on a ramp. So this is one example of a system. There is a certain amount of potential energy stored in the system when the ball is at the top of the ramp. As the ball rolls down the ramp, the potential energy is converted into kinetic energy. The kinetic energy is converted back into potential energy as it rolls up the opposite side of the ramp. So if you look at the example here, we have high potential energy and low kinetic energy. It's not moving yet. As the ball rolls, we know it's going to be picking up speed. We know that because it's losing height, the potential energy is getting smaller, the kinetic energy is getting bigger. And then as it goes up this side of the ramp, we know they're going to switch again. It now has high potential and low kinetic. So that's what we're looking at in the experiment. And we are seeing that the kinetic energy is converted back to potential energy as it rolls up the opposite side. So an ideal system without friction or air resistance, the ball would roll a height equal to the height it started. So what it's saying is in a perfect system with no interference like air resistance, friction, something that's going to slow it down, it would go exactly to the starting height. But we know that we're not in a perfect, system without interference. We do have the effects of friction and air resistance. So that ball is probably not going to make it exactly up to the same starting height. So if there was no ramp opposite the first ramp, the ball would just continue rolling at a constant speed forever until a force acted on it. And we know that that is Newton's law. We talked about that being Newton's first law. So that's what it's saying here. It would just keep going. So we know that some of that energy is converted into heat in real systems. So in most real systems, friction and air resistance slow objects as some of the energy is converted into heat. A ball rolled on a ramp will not reach the same height as it started. The ball will eventually slow to a stop. So we know that if it's going to go back up on the other side, it's only going to go up just not quite as high. And then we know that the final position, if it were to just roll on forever, that eventually friction and air resistance would cause it to stop. So the amount of potential energy in a system of object changes with the distance. So we know that the distance between the earth and the ball on the ramp changes the amount of potential energy in the earth ball system. So here are the formulas that you need. You've probably seen this in the lessons before, so that you can calculate the gravitational potential energy. We know it's gravitational when it's starting at a height and dropping. So the amount of gravitational potential energy that a ball has when it is raised some distance above the ground can be calculated with this equation. So you do need to have this in your notes. And I would also include a sample problem in your notes as well. I would also write this out. GPE is the gravitational potential energy. So that is written out in joules. And basically you're multiplying these factors together, and the gravitational potential energy is expressed in joules. That's with a capital J. We know that M is the mass of the object. It's always in kilograms. And then G is the acceleration due to gravity. This number is always constant. So this number, every problem that you work solving gravitational potential energy, the G in the middle right here is going to be this number, 9.8 meters per second squared. Okay, so always the same. And the H is going to be the height in meters. Okay, so make sure you notice those units of measurements, kilograms, this is meters per second squared, and height is in meters. So the amount of kinetic energy that a ball has when it's moving can be calculated with this equation. Okay, this one's a little difficult. You have to use some of your math skills, but you know that kinetic energy, also measured in joules, M is the mass of the object. Okay, there is no height as a factor here. So we don't have the height and we don't have the acceleration due to gravity. Okay, so now we're looking at the speed. We know the ball is going to be moving, so we have velocity. And we're calculating velocity in meters per second. Okay, don't get these two confused. I've had students that try to start squaring numbers with meters per second when they're using this formula. There's nothing to square here. This is just a unit of measurement. But down here in this formula, you'll notice that this is the velocity squared. So you are squaring this number. So if no energy is lost to heat, the potential energy of the ball before it's released should be equal to the kinetic energy of the ball at the bottom of the ramp. Okay, so we're seeing that eventually those two numbers would be equal if all the factors, if there's no energy lost to heat or friction. So in the experiment, you're going to explore how the potential energy stored in a system changes as the distance between a ball on a ramp and the surface of the earth changes. And you will use your observations to design a marble run. So that's our background information. Now we're getting into the experiment part. So you'll notice you have your lab report here again. It's got some information saying you're going to submit your lab report in the next lesson and that you're going to follow the instructions on the screens to do your investigation. Okay, so this is telling you do not need any lab materials. You do not need a marble, a ramp, anything like that you're going to go through on these next screens and see exactly what you need to get your data. The guidelines and the rubric are helpful to look at so that when you're writing your answers, you know what I'm looking for when I'm grading to get all the possible points for each answer. So make sure you read over that before you submit your work. All right, so we are getting started. Here is question number 1 on your worksheet. It's the question that you are seeking to answer in your investigation, and that's, here we are. How does the amount of potential energy stored in a system change as a ball is placed at varying heights on a ramp? So as you work through the investigation, you should gather evidence to support your claim that answers this question. So here we go. This is Marble Run A. So in this simulation, there are 3 balls with 3 different masses. So that means these 3 weigh different amounts. This is 1 kilogram. I won't hover over. So we'll get back to that one. But maybe there it is below. It kind of pops up in a tricky place. You'll see it pop up. So what we're doing is you have 3 balls that are different masses and a sensor timer that measures the time it takes for the ball to travel 1.0 meters, so just 1 meter. So let's kind of take a look at what we're dealing with. We know in an experiment we have variables, right? We have an independent variable. That's the thing that we are purposely changing. And in this case, we want to measure the ramp height. Remember, how does this height affect the potential energy? So that's our independent variable. The dependent variable is what we're measuring, right? So we're measuring the sensor time that measures the time it takes for the ball to travel 1 meter. Okay, so it's basically calculating the speed for us, but that's what we're measuring. That's the dependent variable, the time it takes for the ball to travel 1 meter. So you'll select one of the balls and record the mass in your lab report. Release from 0.5 meters and then record the time it takes for the ball to travel. Reset it and then repeat for each labeled height. So I have to scroll up so you can see. This is a little bit bigger screen here. We're starting here and then you've got to do it for each of these. Okay, when you're doing an experiment, you should do 3 trials of each one. So on this recording, I'm not going to do that many just for time's sake, but when you're doing your trial, there should be a box for multiple trials for each ball at each height. And then you'll average those together. So let's see if we can do this so you can get an idea. We've got the first ball. Trying to find the, get it to show the, I'm not sure why it's not showing. Let me see if I reset it. This is the 2 kilogram. This is the 3 kilogram. So the yellow is the 1. Okay, so this is the lightest ball. And we're starting it at 0.5. So on your data chart on your page, kind of look where you are and see what you're writing down. 1 kilogram ball at 0.5. I'm releasing it. It takes 0.36 seconds. So then we start at 1.0. Oh, I have to reset. You have to click the reset button. Sorry about that. So we're starting again, putting the ball on the ramp. Okay, it takes 0.24. So you have the 1 kilogram ball to 0.24. I did it again. I didn't reset. Okay, so now we're at 1.5. And it takes 1.43 seconds. So at 1.5, it was 1.43 seconds. Now we're going up to 2. Now it's 0.14 seconds. So you can see it's getting a little faster. Okay, now we're at 2.5. It took 1.4 seconds, so we're resetting there. And then the last one is the highest, 3 meters. And we're releasing it. It takes 0.11 seconds. Okay, so not even a full second on most of these. All right, so we're done with this ball. And now we're trying the red. So we're starting again at 0.5. You're releasing it. So this is a heavier ball. In your notes or in your data table, look, you're at the 2 kilogram ball. You've dropped it from 0.5 and it took 0.36 seconds. At the 1 meter mark, takes 0.24 seconds. At the 1.5 meter mark, I need to reset. Reset. The timer kept going. So 1.5 takes 0.19 seconds. I'm gonna reset that. Now we're at the 2.0 mark. 0.16 seconds, 2.5 mark, 0.14 seconds. So if you're writing this in your data table, hopefully you're seeing some patterns there. And then the 3.0, 0.11 seconds. So hopefully you're seeing some patterns. Okay, and now we're going to use the heaviest ball. This is the 3 kilogram ball. Okay, so holding it up to the 0.5 meters, 0.36. The 1 point, I didn't get a good grip on it. Hold on 1 second. It was spinning around, so that could have affected our results. So 1.0, let me reset. 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 Okay, here we go. 1.5. 0.19 seconds. Okay, here we go. At the 2.0 mark, it is 0.16 seconds. 2.5 mark, 0.14 seconds. And finally the 3.0 meters. So 3 meter mark, 0.11. So hopefully you see that pattern. You have all of that written on your data table on your worksheet. So now, based on what we saw there, we're going to drag the ramps from the toolbar to create a track and then drop the ball on the ramp and try to make it to the other side. We've got to consider how the potential and the kinetic energy of the ball changes as it moves across the ramps. So these are the pieces that we're able to use. Okay, this is the ball and it's going to drop. So we've got to choose our pieces and figure out, let's look again at what we're trying to answer so you can see that. So in the model that we're building here, so you're making, again, it's a simulation, you're not actually building a model. You drop the ball on the ramp and we're just trying to get it to the other side. So thinking about the potential energy, remember with the ball dropping and the speed, so kind of think about the picture you saw at the beginning of the lesson, how the energy of the ball changes as it moves across the ramps. So maybe we want to start it here and let it go up and jump, and then maybe fall down. Oh, I don't know if that'll work. Let's see if we can replace it. I don't think it's going to bounce. Can we put this one back? We'll just experiment. We'll see if we can get 2 G's to fit in here. So here's our design. Let's see what happens. All right, so we drop it down and it didn't have enough energy to do anything here. So if we reset, we know that we're going to need something bigger for it to move. So reset. Let's try this. We need something big, right? And then let's see what happens if we put this here. So it's still pretty big there. And then let's see if we, I don't know if we even want to, we want to just have it jump, right? And see if maybe this one would be better. Okay, so you're just experimenting to see what would happen. So we're taking the ball all the way over. Nope, it's not even moving. So you're going to experiment with moving these things around to try to get the ball to go all the way to the other side. Okay, so you may have to do this quite a few times to figure out. From there, you're going to be writing in your conclusion. So you'll need to draw a picture on your Word document. So let's take a look where you're going to put that. You don't want to clear out your design until you can either take a screenshot, like use the snipping tool or that Featherlight tool, but you'll go to the Word document, right? This is where you're typing in all your answers. So you have your data table filled in, you've started to write your conclusion, and now develop your model. So that's what you're taking out of that little part we just did. You could make a whole lot of spaces here, and you could, let's see if we go back. We could go to the Featherlight where we're able to take a screenshot and we copy it and go back to our document and paste it. You can do that. Or if you don't know how to find that tool, which is something you can download on your computer, it's called Lightshot. That's what it's called. You can see it on the screen. It just popped up. And that's on Windows 10. They have Lightshot. There's also a snipping tool. You can download that. But you're able to cut and paste out a little picture, put it there, and you have it. If you can't figure that out, print this out. So leave yourself enough space because there's still another question, and draw it in. Okay? You can draw that portion. And then the final part here is just saying, using what you learned, how did you design it? So then you're going to explain, what did we do here to get the ball over to this side? What worked? Okay, so trial and error, make sure you're answering your questions thoroughly, explaining what design worked. Okay, so you'll have this here. Going back up here to the conclusion, what conclusions can you draw about how the potential energy stored in a system changes as the ball is placed on varying heights on the ramp? So when you write a conclusion, you need to go back up to your data and see what those numbers show. right? We saw that the higher the ball was, so these speeds here are going to be the fastest. So you would write that in your conclusion. Based on the evidence I observed, or based on the data I collected, I saw that all three mass, the mass of all three of the balls didn't matter, but the height of the ball did matter. And so you're able to calculate the potential energy there, and you're able to see the time it took to travel. You can put that in meters per second. It's distance over time. And then you can also calculate the kinetic energy. So when you're filling all this in, you also want to have a data table showing what you collected. So you can draw that in. You can write it in here. There's places to do all of that. So just make sure you read carefully. And if you need to add something, you can. And then you will answer based on that evidence. So write an evidence-based claim. That's what that means. So using the data I collected, I saw that the ball with the mass didn't matter, but the ball that was dropped from the highest height went the fastest. And you could plug in some of your data there. So then it's not just one sentence. Your conclusion is about 3 to 5 sentences. They're complete sentences. Make sure they make sense. If you're typing them in, make sure you spell check. Okay, you have that tool. So you're 8th grade students, most of you are about to go to high school. You need to turn in work that does not have spelling and grammar errors. There are too many programs, especially using Word, that show you misspelled words. So if there's red squiggly lines, you need to fix it. And then so you have a 3 to 5 sentence here. You've got your model here. It says develop the model that shows the amounts. So you can snip that in. And then you can write how you used what you learned to design that. So you're going to tell me here how we figured out what was going to work. And make sure everything else is answered. Okay, when we're looking at the tools you use to collect, what did we use? We used a simulation lab that had a ramp, and it had a sensor, right, that collected data there. So those would be the tools we used. What procedure did we use? This is you're going to specifically tell me the steps that we took. We took 3 different balls that were 3 different masses. We dropped them from several different heights, and we recorded that data. It needs to be a detailed explanation of the procedure. That's the steps. So think about like a recipe, what you're following to be able to write this answer out. It should not just be one sentence. And then make sure you have your variables correct. Remember, the independent variable is what we were testing. Okay, so the ramp height, the dependent variable, what were we measuring? We were measuring the speed. And the control, what things did we not change? Okay, we didn't change the size of the ball. We didn't change the ramp that we used. We did change the height, but we kept the same ramp. And we did not change the sensor. So those are the things that stayed the same. And then we saw the purpose of the experiment several times. So remember, save your file. From there, you're able to go into 1.12 and upload it into the Dropbox. So if you have any questions on the lab, please let me know, but that should get you started and help you successfully complete your first teacher graded assignment.